Hello, I hope you've all had a lovely day. Now, only the people in the room will understand the nuance about that. I hope you've had a smashing time. I'm Alan Willison, I'm the chairman of the Hertford Astronomy Group, and it is my pleasure to welcome you to this meeting. It's lovely to see familiar faces and some new ones. And to the new ones, I do say, please don't go away without saying hello to one of the committee. This mob down here, one over there, one at the back over there. We don't want you to go away thinking what an unpleasant group they were. So do make sure that you say hello to us. And to those of you on Zoom, a very special welcome to you as well. I hope I'm looking in the right direction for Zoom. Perhaps my technician will tell me. Into that camera. You can tell I'm new at this, can't you? So, hello to you on Zoom. I hope you're all very comfortable and that you also are having a nice time. For all of us, can I say that the meeting is going to last about an hour and a half. It's going to be, Martin is going to give us a little bit of a talk about things in the night sky. And then following that, we've got Roger O'Brien, who's going to talk to us about the Starship project. So, those of you in the room, can I ask that you've got your mobile phones switched to silent? And those of you on Zoom, can I ask you to keep yourselves muted and to keep your hands away from the space bar, because that has the habit of turning the sound on. There will be opportunities to ask questions, and could I ask you, could you keep the questions until the end of the talks? Those of you on Zoom, if you can submit your questions via the chat facility, we will make sure that they're read out at the meeting. So that's enough from me. I'm now going to pass you over to Martin, who's going to give us his presentation. Over to you, Martin.
Thank you, Alan. Okay, everything right? Okay. Hi, everybody.
Hello.
Nice to see you all after our break. All keen and eager to get out and do some astronomy, I hope. I'm going to talk a little bit about galaxies, well, specifically the Andromeda Galaxy, because we're now in galaxy season. It's ideal position for looking at galaxies, so this is probably the only one that if you're in a dark skies area, that you can see with the naked eye. Certainly with a telescope or binoculars, it appears as a misty blob. But I'll put a bit of information there about the specifics. So it's if you find the square of Pegasus here and follow the line down 1 star, 2 star, and then you come up 2 stars and it's at the 3rd star, it's about there. So Andromeda is the closest spiral galaxy, slightly larger than our Milky Way galaxy, and it's actually moving towards us at a pace. The next couple of million years it'll be closer. I think it's about 2 million years it starts to interact with our galaxy. So, but I'll stand to be corrected if that's incorrect. But it's 2 million light years away, and I've got some images here of it. So this image here was taken by one of our astrophotographers, Michael. And as I said, it's visible by it's the only large spiral galaxy apart from the large and small Magellanic clouds in the southern hemisphere, but we can't actually see those from here, Magellanic clouds. They are smaller galaxies. So, planets galore. So we've got Jupiter coming up in the east sky. It's quite bright at the moment. This won't be able to see Neptune with the naked eye. You probably won't even be able to find it with a telescope, but it is up as well. Also Saturn's quite low at the moment, but Steve's been taking some spectacular pictures of Saturn as well, so we have been getting a few clear nights, which we haven't had just recently. Unfortunately all my equipment's packed away because going away in a couple of days' time, but I have been going out with my binoculars and having a look. So if you're an early riser, Venus and Mercury are coming up with the Sun. I unfortunately can't see the eastern sky because there's houses in the way, but if you've got a clear view of the east, it's quite quite a spectacular view. But be careful not to stare directly at the Sun as it's actually rising. So there's a bit of information there. Elevation 15 degrees above the horizon, which is quite low. So we're coming up now to autumn equinox. So that's equal day and night this month. I'm trying to think the exact date. It's towards the end of the month. I've got it on here. Here we are, September the 23rd. So that's when we start to move into the winter sky, and that then changes what we're looking at again. And then for astronomers, obviously the winter sky is more beneficial because we get longer periods of darkness, and for imaging it's better because we can have longer exposures also for what we're taking images of. But then we have to put up with the cold weather. And harvest moon coming up very shortly. I think that's on the 29th of September. So I was looking at the moon last night actually, and it's really bright, almost directly overhead. But it's half moon at the moment, so being so bright, but it's quite close to us at the moment. So that's one to put in your diary. Have a look if it's a clear night. Definitely go and have a look at the harvest moon. Yeah, it's quite interesting because it was a pagan festival. Just reading my notes here, and it's a Heian, a Japanese holiday spanning 3 days. So they obviously take more interest in the heavens than we do here in Britain. Okay, so another object which is quite abundant at the moment is the Cygnus loop. And Cygnus, this one you can see quite clearly, it appears like a cross almost directly overhead at the moment. This is a supernova remnant. I took this a couple of weeks ago, and it's a massive star that's exploded approximately 5,000 to 8,000 years ago, and this is the material that's been expanding away from the supernova. But if you actually can't see it with the naked eye, but if you could, it would actually occupy 2 or 3 moons in width across, so it's quite a large element in space. So moving on to the planets. So this is one of Steve's images of Saturn. I know he's taken some better ones since because we've had clearer skies, but unfortunately I haven't had a chance to add them to my presentation. Sorry, Steve. But we could definitely I think it's a good image because you can see quite a few of the moons here, which Steve's nicely labelled so we can all see exactly what we're looking at. So I think that's, considering the conditions that you took that in, I think that's a pretty good image. But yeah, Saturn is quite low. But if you've got a pair of binoculars or a telescope, you can definitely see the rings. You can see that it's not it's a ringed planet. So this one here is the Eagle Nebula, which is a summer constellation, but it's quite low, very difficult to get. But this particular image, taken by one of our astrophotographers, Kevin, is absolutely has won quite a few competitions on various websites. But you can probably recognise the pillars of creation in the centre there, which was the famous image that Hubble took many years ago. So this is another one of my images. This is the North American Nebula and the Pelican Nebula together. I was just testing out a new telescope. I'm quite pleased with the results of that. people quite often ask me about the colours that in the images. They're called false colour for a reason, because they are false, not the true colours. But the reason I use them, this is called the Hubble palette. The reason I use them is because they you get better definition. You can bring out the nebulosity much easier, and it doesn't, certain colours enhance the contrast, and that's the reason I do that. Moving on, so this is another one of Steve's images. Something I do love imaging, and I think that's a superb one, of planetary nebulas, and that's the Dumbbell Nebula. Now, a planetary nebula is not a planet as it's named. It's a misnomer, that. They're actually stars very similar to our sun. That they reach the end of their life and they start to cast off the material. They become a red giant, and eventually they expand beyond their ability to sustain the material anymore, and it's cast off like you can see there. And then the dying star shrinks down to become a white dwarf. And the white dwarf shines quite brightly, so it illuminates all the gases around it. So we can see there the bluey colour is normally oxygen, and the reddy colour is more sulphur and hydrogen in the material that's coming out of the planet.
Which is the white dwarf?
The white dwarf will be right in the middle,
Okay.
it'll be about there.
Yeah,
So this is another image by Kevin Noble. So this is the Eagle Nebula again, but in a much wider focus area, so you can barely see the pillars of creation. They're right in there, but he's picking up all the material around the nebula, and you can realise just how much material there is around these nebulas. But then most of these nebulas will be in the Milky Way. They're in the band of the Milky Way, because that's where all the material in our galaxy is congregated. I put this one in because I thought it was quite nice, because this is something most people can do, the Milky Way shot. This is just on a tripod with a standard digital camera and done them exposures. And Michael took this in Stevenage, so it's not exactly a dark skies area, from his back garden, and you can see quite clearly the Milky Way going through the centre there, the material. Next is another galaxy from Kevin Noble. This is the Pinwheel Galaxy. It's quite difficult to get that in so bright, because it's not a particularly bright galaxy. But the material you can see there, the reddy coloured material in the spirals, is hydrogen, and it's usually areas of star growth or star birth going on around those areas. And as you move towards the centre, the older stars tend to congregate. This is another spectacular picture by Steve. This is one of my favourite objects to try and capture, the Crescent Nebula. This is also in Cygnus the Swan. It's, as you follow the arms coming out, and you come along the tail, it's about halfway down. And this is a slightly different nebula. It's actually a Wolf-Rayet star, which is in the centre here. This is this star here. And this star is so hot and so massive and so energetic that it's actually throwing off its own material before it becomes a supernova. They live for very short lives, but this is all the material that's being thrown off by the star itself, and it's actually illuminating it. But that's an excellent picture. Put a planet in. This is one Michael's taken of Venus, which I thought was quite good. You can see, very difficult to get Venus because it's quite bright sometimes and to get that crescent effect. But I think he's done a superb job there. Just moving on. I won't take up too much of your time, and that's it really. Are there any questions? I shall hand back to Alan. Thank you very much.
Thank you very much indeed, Martin. Absolutely super. While Martin was talking about taking the photographs, it's a good time to sort of promote that within our club we've got a specialist photographic section, HAGAS, Hertford Astronomy Group astrophotography section. And we've got a meeting on the 17th of October, Tuesday the 17th of October, at the Stanboroughs Club in Hoddesdon. And they've got Glenn Clowder, also known as Astro Bloke, on his YouTube channel coming along. If I can really sort of encourage those of you who've thought about connecting a camera to a telescope at some time, but you're not quite sure, just remember everybody is a beginner at one stage. So don't be afraid. If you want to go along, we've got some fantastic people, super members, who would be only too willing to share that expertise with you. So don't be afraid. Put the date in your diary. It's on the website, 17th of October. Please note they're Tuesdays, not Wednesdays, as they have been in the past. Moving over to the main part of this evening, many of you know the history of how our club formed, and we go back to 2004, and it's a real privilege to be able to invite, if I say the father of the group, to come back. It's exciting times in astronomy. It's been exciting times for quite a while, but in terms of exploration, human exploration, we are right on the edge of some very exciting stuff coming along. And of course, part of that is the Starship project. And to tell us about that, and probably a few more things as well, please give a big warm welcome to our speaker, Roger O'Brien. Over to you, Roger.
Now, where have I got to stand? About here, right, okay. I've got to find it now, haven't I?
No pressure, it's on the screen behind you as well.
Right. There we are. What's a start? It's always nice when it actually all comes up, isn't it? You know. Right. So, SpaceX. I think you've all heard of SpaceX, yes?
Oh, yeah.
Yes, good.
Quite, thank you.
They've designed this thing called Starship. When Alan asked me to do Starship, I said, well, I don't know anything about it. And I'm not entirely sure. I know a lot more now, but we'll see how we get on. Okay. So, actually, it's a damn silly name, because it's not a starship. It's not going to go anywhere near a star. It's not even going to go near the sun, you know. But anyway, it's quite a good name in that sense. I mean, it's got this thing of being easily recognisable and pronounceable and so on. I found when I was looking at the stuff to do this that everybody uses all the names kind of miscellaneously. So they talk about the Starship project. Well, actually, strictly, the Starship is the bit on the top. And the booster is sometimes called the booster, and sometimes it's called the super heavy booster. But sometimes it's called Starship. So if you find I'm getting confused, hard luck. So I shall be looking at the whole stack, and I'll try and remember to use Starship for the orbiter. Of course, it hasn't gone in orbit yet. Don't forget about that. Now, Elon Musk, as usual, has got his publicity machine going on this, and it's brilliant. I'm not quite sure how he gets away with some of the things he says, but there we are. And one of the things he keeps talking about is Mars. Starship is supposed to be going to Mars. It's supposed to be taking 100 people a time to Mars. If I sound just the teeniest bit sceptical, I am. It's a big vehicle. But I tell you what, if I were asked to go to Mars on that vehicle and 99 other people were due to go with me, no. It's not big enough. I can't see how they could cram the life support systems and all the other stuff in at the same time. I mean, yes, you can get 100 people in, but would you really want to deliver 100 corpses to Mars? No. I'm doing my usual thing of being a nasty, sceptical old git, which is, you know, my natural feature. So there we are. And this is one of the things that they've come up with. SpaceX have come up with, and as you can see, this purports to show Starship boosting up from Mars. And you've got down the bottom here, you've got some kind of Martian base. It looks a bit Logan's Run to me. Pity they haven't got Jenny Agutter, because I rather fancied her, but still. Okay. Anyway, of course, this is fantasy of the. Hasn't got into orbit yet. So. Anyway, there's a minimal mission, and that minimal mission is to get the bit that I've put the red ellipse round into orbit. That's the minimum mission. So we've taken off all the science fiction stuff. We're not bothering about going to Mars and all that stuff for the moment. But this is quite a big rocket. And the bit with the red ellipse around it is 50 metres tall. And the bit that's supposed to move it up into the sky is 71 metres tall. Now this is pretty big. Lift-off weight will be about 5,000 tonnes. That's considerably bigger than Saturn V, the whole stack. It's bigger than the Russian M1, and it's bigger than the SLS, you know, the Space Launch System. The idea is that this little spaceship, the black bit there, should be able to take 150 tonnes of stuff into Earth orbit, low Earth orbit. This is it's really the bar, you know, if you can't get over that bar, you're not getting anywhere. And I'm probably not supposed to say this, but of course SLS can't do it. The Space Launch System is way short of 150 tonnes at the moment. It's short of 135, which used to be the figure. So SLS is perhaps a bit of a disappointment in that way. Basically, the real problem with SLS, by the way, is that the second stage, which they borrowed from the Delta Heavy, isn't powerful enough. You know, they need something about 6 times more powerful, carrying a lot more fuel and so on. And that's probably the next phase, but they haven't got there yet. Anyway, apparently Elon Musk looked at the first design for this thing and he said to the guys, it's got to be more pointy. And they said, why? And he said, because it will be fun. I mean, you know, that's design strategy for you. I keep getting the feeling, looking at it, that he's been seeing too many Von Braun movies. I mean, I'm old enough to remember them. I don't know if any of you do remember them. I think they were actually produced by Disney. You know, do you remember the one for Mars? 13 rotating spaceships. When they got halfway to Mars, they swapped the crews round so they wouldn't kill one another. Brilliant idea. Nobody's ever got anywhere near that since. Of course, they didn't get near that. It was only a cartoon, but there we are. Now, you've got to keep reminding yourself, if any of this is going to happen, they've got to get Starship working. And that's the whole stack. The booster's got to work, and the Starship on top of the booster's got to work. And it's got to get into orbit. And of course, that's only the first step. If you're talking about going to the moon, going into Earth orbit, it's a nice, useful bit, but it's only the first stage. Now, it's a very powerful booster. Staggeringly powerful. It will be more powerful than any previous launcher. Arguably, it already is more powerful. It depends how you define whether a launcher is successful if it only just sort of cleared the launch tower. Now, Saturn V, of course, is the one everybody knows about. An incredibly powerful rocket. But actually, the Soviet N1, which was its rival, was more powerful in terms of thrust. But the N1 never reached operational status, which is a bit of a shame, but it never did. And the SLS stack, the Space Launch System, that's the Artemis side of it. That exceeds a Saturn V in thrust, but it's heavier, so it can't launch as much payload. So that's what a Saturn V had for liftoff thrust. If you don't know what a meganewton is, it's not going to do you any harm. It's just a measure of thrust. It's 1,000,000 units of thrust. The SLS Block 1 is, as I said, more powerful than a Saturn, but it's heavier, so it can't take as much payload. The N1, which was the Soviet rocket, was considerably more powerful, but was only actually rated for 95 tons in low Earth orbit. And the Super Heavy booster is rated at 74.5 meganewtons, so that's well over twice what the Saturn 1C could do. Saturn 1C was the first stage of the Saturn V stack. They haven't achieved that thrust yet, but they're not far off it, so I think they will. And it's a bit like recording, I mean, some of you have done these things, I'm sure Martin will back me up on this. It's a bit like recording the magnitudes of stars. It depends entirely where you look. You know, the more places you look, the more different answers you get. So these looked all right, and I stopped. So there's the Starship stack on the right, as you look at it, compared with the others. You can see it's taller than a Saturn V, which in turn is taller than an SLS Block 1, which in turn is taller than a Falcon Heavy, which in turn is taller than the Space Shuttle. The Saturn V is the only one of those, I think, that has really become an iconic feature. I think most of us would recognise a Saturn V, possibly the shuttle as well. Falcon Heavy, of course, has been doing a great job as a commercial launcher, but I don't think it's quite got past the Saturn V. The SLS has had a couple of successes, including the moon orbiting Artemis 1 last year, which put the Orion capsule through its paces, but without a crew. I think this is quite a sensible idea. You know, it's a nice idea to know it works before you actually send people. Of course, they didn't do that on Apollo, did they? They took a risk and sent Apollo 8 off. First time anyone had been outside Earth orbit. And they got away with it, didn't they? And do you remember that wonderful picture? You know, the Earth rising over the moon. Yeah, that picture. That's the space race for me. Okay. Oh yeah. I thought I'd deleted this slide, but obviously I haven't. I have to talk about it now, won't I? Yeah. You never quite get to the end of these things. The last Apollo, Apollo 17, had the most powerful booster. They'd learned a lot in the previous missions. So they actually had 141 tons in low Earth orbit. The objective was 135. So they were 6 tons over, which is not bad. Starship's 150 tons is an estimated maximum. But remember, with Apollo, you've got your payload is on the top. Starship, like the shuttle, the payload goes inside. So the whole thing that goes into orbit is considerably more massive. 150 tons is the useful cockpit. It seems a little unfair to describe a spaceship as not useful, but you know. If they can ever build this 100, well, not build it, if they can fit 100 people in it, as I said, I'm not going, into Starship, that would need an in-orbit mass of 225 tonnes, that's 75 more. So they would have to use expendable versions of the booster and the Starship. Because although that business of being able to reuse them, and particularly the business of being able to land the boosters back again, has enormous advantages, you don't do it without using fuel, and actually you have to reserve about 10% of the fuel to do it. So if you want to get absolute top performance, you have to chuck your boosters away, which is what everybody used to do anyway. Just the weight of the propellants in the booster is 4,100 tonnes when it's fully loaded. That's more than an Apollo Saturn V stack, which was 3,100 tonnes. So this is going for broke. This is a big effort. That's a schematic of the whole stack on the launch pad at Boca Chica. This is the latest version of the launch platform. I don't know, yes, you can. I'm sure you can see my cursor here. Can the Zoom people see my cursor? Oh, good. Good Lord, that's a start. This bit here is new. I lifted the whole launch system up on a little platform. This is to enable the thrust to disperse more, and also to give room for a water deluge system which they had to build. You may think the Super Heavy booster doesn't look particularly big. It's comparatively svelte. It's slightly narrower than a Saturn V. It's 9 metres as opposed to just over 10, and it's 71 metres tall. But they're using heavier propellants, so there's a lot of stuff in there. Now, in April this year, they tried the whole thing out, and the thrust of the booster did a lot of damage to the launch pad system. I'm probably going to get hung for saying this. I think this should have been foreseen. You know, they've been boasting about how powerful this thing is. Didn't anybody work out that it might, you know, I would have thought it was a reasonable thing to work out, you know. Oh, I'm just being a nasty old curmudgeon as usual, but anyway. So the result, the pad has been considerably modified. So the rocket's been raised up on this steel platform. They've installed this water deluge system, which throws, you've seen it on the NASA Canaveral launches, you pour jets of water in under the launching rocket, and that of course cools the exhaust from the rockets down and slows it down. So what you get is thousands of gallons of water instead of very superheated steam, very superheated steam. I actually did a talk many years ago at the Science Museum where I was talking about the future of the steam engine. I was citing all these rockets that are powered by liquid hydrogen and liquid oxygen, which apparently wasn't what they expected. Well, tough. So they had to install these huge tanks to hold all the water for the deluge. I mean, you can't just turn up on a tap. There's just not enough, you know. And pumps and so on, and 5,000 tonnes of extra concrete. Apparently they have fleets of concrete trucks driving round and dumping their load and driving round and getting another lot and driving round again. Back to 2018, bit of background. Falcon Heavy, the workhorse of SpaceX. It's essentially a launcher. It puts the Starlink satellites up, which I'm sure all of us amateur astronomers are duly grateful for. It's also launched a number of communication satellites and so on. It shows you how much room there is in a Clark orbit, that despite the fact that there are dozens of communication satellites up there, they don't bash into one another or anything like that. This was a demo mission in 2018, and it was a demonstration to show its capabilities. So the Falcon Heavy, it's a modified and strengthened Falcon 9 with 2 strap-on boosters. So far, that doesn't sound particularly different. But each of those boosters, instead of, as has been typical for most launches over the past 20 years, instead of those being solid boosters, there's simply 2 more Falcon 9s which have been modified to function as boosters rather than as the main thing. So the main rocket is a strengthened and lengthened Falcon 9, and it's got 2 more Falcon 9s stuck on either side. They use cluster engines, 9 to each of those 3 bits. That's rather Russian. The Americans have always generally gone in rather, for larger engines. So, for instance, the Saturn V had 5 engines, wasn't it? 1 in the middle and 4 around the outside. So that's rather Russian. But Russian rockets tend to be sort of a cloverleaf pattern, and these are tall and slim. So the rockets have a NASA look, but they've got Russian style engines. In fact, there was a story that Musk got his early engine designs from the Russians. Whether this is true or not, I don't know. I heard it some years ago, and when I tried to check it up for this talk, I couldn't find out anything, so I gave up. This demonstration carried no useful payload. There was just a Tesla car, which is quite a brilliant idea, but you know, and they got it to past Earth's escape velocity and vaguely in the direction of Mars. And this is the famous publicity picture, the Tesla car reflecting the sun off its sides. There's the Earth in the background, and there is this dummy. I'm glad it wasn't a volunteer, because he wouldn't have come back, or she wouldn't have come back. And because they talked about it being en route to Mars, the Mars connection's a bit on the loose side. Actually, the Tesla never went very near Mars. It was just sort of chucked out in the vague direction. They got, we believe, slightly beyond the orbit of Mars, but there was no tracking of the Tesla by then. So it didn't rendezvous with a red planet. It wasn't even aimed accurately enough to have attempted it, even if it had the right equipment to do so. So no orbit or landing. It took about 6 months to reach Mars's orbit, we think, because we don't know if it got there. This is the famous Tesla cockpit. There is the dummy's space helmet and so on. The dummy's holding the steering wheel. How much use a steering wheel will be in orbit, I'm not entirely sure, but perhaps we shouldn't ask. And there is the famous "Don't Panic" on the dashboard, best place for it. And they had David Bowie's Space Oddity on the stereo. And of course the stereo wouldn't work in an open cockpit like this. You wouldn't be able to hear it, but there we are. Perhaps he could hear it on his in-helmet headphones. The Tesla only had a short service battery, so it made these transmissions and that was it. Headline grabbing. And it just went on its way, and nobody's ever seen or heard of it since, which is what it was supposed to do. Now, okay, there's some Hitchhiker's Guide jokes and things like that, but actually, to get anything up into orbit and then out into the great beyond is no mean feat. And this was the first time they tried it. So There's something done there. And this is the famous landing, simultaneous landing of the two boosters back at Canaveral. Now that is no mean achievement. This is a step forward. I remember watching this, and when I first saw it, I thought, well, that's a cartoon, you know, it's one of these. I can't remember, what's the name of the...
CGI?
That's it, yeah, that's the stuff. That's what I thought it was, but it's not. It really was like that. They lost the core booster, the central booster, because a fault in one engine meant that it couldn't land back. But they managed to land the two side boosters, and they've been landing one booster or two or three or whatever on a regular basis. And they can reuse them. I think this is the most important development in rocketry since they decided to build step rockets or stage rockets. The Starship and the booster are designed to be reusable, but the prototypes that have been used so far are expendable. But eventually the boosters should be recovered and reused. They should come down properly. And SpaceX has announced plans to refuel Starships in orbit and either on the moon or in lunar orbit, or possibly both. This is pretty ambitious. Again, I'll put on my curmudgeonly hat. There you are. They've got to get in orbit first. Yeah, there's a few things they've got to do. Back in 2018, round about the time of the demo mission, Elon Musk said we'll put human beings on Mars in 2026. That's my only comment. I think they'll be dead lucky to get humans on the moon by 2026, because they're way behind the schedule. We should be used to this. I mean, SLS is, 5 years at least behind the original schedule. I don't think anything's ever going to beat JWST, isn't it? Original launch date was 2013. Wasn't quite up to schedule, you know. Okay, but they did get people to the International Space Station and brought them back safely in April 2019, so that was good. Now, Starship's booster is just this simple cylinder. Contains fuel and oxidizer tanks and 33 engines. In one way, this is one of the strengths of the idea. The engines are effectively mass-produced. And once you can do that, it is relatively easy to produce to a fairly high specification. They're guzzling, when it works fully properly, they'll be guzzling 4,100 tonnes of a mixture of liquid oxygen and liquid methane. Now, you've got to remember that SpaceX's designs change. They change more often than fashion does. The Falcon 9, which has been a great success, but originally it started off with 9 engines that were in 3 rows of 3. And then 9 engines with 1 in the middle and 8 round the side. I can't think of another configuration, but they probably could one if they wanted one. I suppose they go 3 in the middle and 6 around the outside or something like that. The central engine and the remaining 8 round the circle is a much more compact arrangement, but it is more difficult to fit the engines in. That's boosters engines, 33 of them. They're the same engines essentially as the Falcon 9, but there are 33 of them. That's only 6 more than Falcon 9 Heavy, which has 3 units, each of which carry 9 engines, that's 27. This is more powerful, the engines can be throttled up higher and all that kind of thing. I thought the engine arrangement was new, and I looked it up and found I was talking cobblers. The Russian N1 had its engines arranged like that. Now that's a little cartoon of its 30 engines, and I then managed to find a picture where you can see 30 engines. I had to put that in to prove that I could copy Cyrillic, not that I can pronounce it very well. N1 had a rather checkered history, and the second launch attempt exploded. It's one of the largest human-made explosions on record. I suppose you've got to regard that as an achievement. I don't think the Russians were terribly chuffed about it at the time, to be honest. And it completely destroyed one of their launch pads. The programme was actually cancelled in 1974, but that was the sort of final obsequies. I mean, it really came to an end in 1970. After they'd had 4 launch attempts, all of which had gone wrong. I think they just said, well, we ain't going to try it again. There's the N1 on the right against the Saturn V on the left, and a human down the bottom looking very tiny. Remember, the Saturn V with the escape tower on the top is 363 feet tall. Personally, I'd have made it 2 feet taller and made it 365, but there you are. The Saturn rocket is so big because partly it has to be, but also the second stage is very powerful, but it uses liquid hydrogen and liquid oxygen. And liquid hydrogen is a very, very bulky fuel, very low density. And that makes the second stage enormous. It's nearly as big as that huge first stage. Got nowhere near as much tonnage of fuel and nowhere near as powerful, but nevertheless. So N1 used kerosene and liquid oxygen, and funnily enough, so did the S1C, the bottom stage of the Saturn V. Kerosene is a good substitute for hydrogen in that it's got plenty of hydrogen, but it's got a lot of carbon in it, so it makes it, the molecules are much bigger, it's much more dense, and it has other advantages. But you don't get as much power per tonne out of kerosene as you do out of liquid hydrogen. Now the super heavy booster is relatively small because it is just one booster. It hasn't got all these step things. And they use what they call subcooled liquid methane and liquid oxygen. Normally liquid fuels are cooled not very far below their evaporation point. But Starship, well the booster actually, is using liquid methane and liquid oxygen cooled almost to solidification. This gives you greater density and makes the liquids much more easily used in pumps. I mean, one of the big problems with pumping a liquid that is on the verge of evaporation is cavitation. If you get cavitation, that is where you get effectively a small bubble of vacuum, when that collapses you can do endless damage to the pump. So looking back in things, or we will be in a second, liquid hydrogen and liquid oxygen is by far the most efficient combination. Well, there is one more. If you fancy getting together liquid hydrogen and liquid fluorine, I don't think I'd like to go anywhere near a site that was using that. But liquid hydrogen is very bulky. Kerosene is rich in hydrogen, but it has the advantage that it stores well and doesn't need refrigeration. Keeping liquid oxygen is very difficult. Oxygen is very corrosive. And liquid hydrogen, because you have to cool it so much, is an extremely difficult substance to manage. So liquid kerosene is quite a good substitute for liquid hydrogen. It's denser and so on, but it doesn't deliver as much power per tonne. Because, and all sorts of different rockets. I mean, we all know how to make rockets, you know, gunpowder and a long stick. I actually made quite a lot of money, well, by my standards, quite a lot of money. When I was in my teens, I used to make gunpowder and sell it, till my father found out. He just told me off and told me I mustn't do it anymore. But anyway, incidentally, if you want to make a nice rocket, make gunpowder and add a bit more niter, and then you make the gunpowder into a paste with kerosene. It makes an ideal rocket fuel. Very good indeed. It doesn't explode, which gunpowder is likely to do. Anyway, now round about the same time that von Braun was developing the V2 missile, Robert Goddard over in the States was developing liquid fuel rockets. And what isn't generally realised, that although they weren't on the same scale as the V2, virtually all the important modern ideas, liquid fuels, turbo pumps, graphite veins in the exhaust to stabilise the rocket, gyroscopes to tell the rocket, you know, which direction it should be going. They were all developed independently by the Germans and the Americans. But Goddard, although he wanted liquid hydrogen and liquid oxygen, couldn't get hold of liquid hydrogen in any quantity, so he settled for gasoline. Gasoline is actually not ideal. It evaporates very easily. And of course the gasoline vapour is incredibly flammable. Now, another feature of SpaceX design. Up till now, SpaceX's rockets in many ways hark back as much to Soviet examples as they do to American ones, particularly cluster engines and the use of kerosene and liquid oxygen. Back in the 1930s, they also used hypergolic propellants. Dreadful phrase to try and pronounce. Now these are fuels and oxidants that spontaneously light. You just mix them, they go off, bang. So you don't need an ignition system. There is a slight problem. These propellants are very toxic and they're also corrosive, so they're extremely difficult to store. They were used on the space shuttle, and they're also used on the Soviet proton rocket. The hypergolic materials were used in the thrusters that the shuttle carried, not in the main engines, which are liquid hydrogen and liquid oxygen. But if you remember, when the shuttle came down, these guys in what looked like spacesuits used to rush up to the back and seal it all up. That was because of the hypergolic propellants, which are highly toxic. Now, Starship and Booster, as I said, they use liquid methane and liquid oxygen. They're very stable when they're pumped. Methane is a good compromise. It's much richer in hydrogen per tonne than kerosene is. And nevertheless, because there is a certain amount of carbon in it, it is much denser. It occupies a lot less room, so you can build a smaller ship and get the same power out of it. So M1 had 4 launches which all failed. Saturn V never had a failure. It had a very, very good record. So does the Soyuz launcher. I think Soyuz launchers had 1 failure in about 3,700 launches. That's not bad. I think we'll let them have 1. This is a picture of a Soyuz launch back in 1975. And whoops, this is a picture of a Soyuz launch in 2018, and you can see not much has changed. This is a case of if it ain't broke, don't mend it. The Americans had a tendency to describe Russian rockets as, you know, a bit like fireworks, you know, light blue touch paper and step smartly backwards. On the other hand, you know, a shuttle or a Saturn V took about 10 weeks to prepare for launch. Standard Russian launch campaign is 7 days. And they say that if there was an emergency on the International Space Station and they had to get the crew down, for instance, they could get a Soyuz up there in 48 hours. Nobody else is even close to that sort of record. Now back to SpaceX, and the 20th of April 23, so not long ago. And as you can see from that picture, it all went slightly pear-shaped after a while, about 3 minutes in fact. Rapid unscheduled disassembly. They blew it up. Quite right, but that's what they did. The Starship and the Super Heavy were unable to separate. Apparently they worked out what was wrong. One version of it is that they needed a longer cable linking the two. Again, one feels they should have checked that out before they sent it up, but you know. It was the first fully integrated test, scheduled to be the whole stack, launched from Boca Chica. Booster would go up 40 miles and exhaust its fuel and would then just carry on in a parabolic arc and crash into the Gulf of Mexico. Starship, which would have only minimal amount of fuel on board, would then get into a suborbital hop which would take it all the way around the Earth and most of the way to Hawaii. As you saw in that picture I just showed you, that didn't happen. Boca Chica, by the way, means little mouth, as of a river. Boca Chica is in Texas, right down by the Rio Grande. So when the Mexicans invade, they'll capture it straight off. SpaceX people tend to refer to Boca Chica as Starbase. The people in Texas have said, well, they haven't filed the paperwork to turn Boca Chica, which is only a small community, into a small city which would be called Starbase. So Starbase is purely unofficial, but of course that hasn't stopped Musk and his mates doing it. So 3 minutes it went up. It got up quite a long way. Things had already been going wrong. Out of 33 engines, several had malfunctioned. They had passed what they call max Q. Max Q is the moment when the aerodynamic resistance to the rocket plus the stress of its own launch builds up to a maximum. So they got through that, which is generally reckoned to be a big hurdle in any launch. But it was after that that it went really pear-shaped, and that was because they couldn't separate Starship and the booster. Because Starship couldn't fire its engines, it remained attached to the booster. The booster was not functioning properly because it should have detached by then, and the whole stack began to cartwheel, which is not a very good idea. So there was no alternative. Launch control aborted the mission, they blew it up. So there it is. Ooh. Starship and the booster. There, long, thin rocket. Now, if you look at a blow-up of that, you can see that out of 33 engines, quite a few have already failed. It's also noticeable that some of the engines are producing virtually no visible exhaust, which is correct, and some of them are producing quite noticeably coloured exhaust, which isn't what they're supposed to do. So definitely things were going wrong. Nevertheless, Musk said, and people backed him up, that this was, anything, once they got past the launch tower, that was a plus. If it blew up after that, well, hard luck. Life can be a bit lumpy at times. Now, this is a picture. Can anybody guess what this is about? If you've already seen it, shut up.
Is that how far it's going? Out of, it's towards the
Very good. It's actually the National Weather Radar from Brownsville in Texas, and it's picking up the plume of the rocket's breakup. So you were 90% of it there. Yeah. This shows you just how much stuff is being chucked out. Apparently there's quite a large party in South Texas which reckons that this is, a major source of pollution. From this particular launch, apparently concrete dust spread over well over 100 square miles of South Texas. I would guess into Mexico, but apparently they're not teaming up with the Mexicans to protest about the thing. Anyway, although the flight ended in controlled destruction, because the launch got off the ground, it's broken the record which the N1 had held for more than 50 years. I just found this picture quite interesting. It's the bottom of the Starship, of the super heavy booster, before they've installed the engines, and you can see from the size of the guys and the size, this thing's big. That's one of the Raptor engines, and that's a Raptor that is optimised for launch, sea level operation. Raptor, of course, is a word coming from paleontology is the wrong word, isn't it? Paleobiology. Raptors, forms of lizards. So that's a lizard. There are 33 of those to power a booster. And they've now developed versions which are optimised for vacuum, and they will be used on the Starship. Starship will have, at least initially, will have 3 sea level Raptors and 3 vacuum Raptors. Well, there's a nice simple diagram of how the rocket works. You'll all be tested before you're allowed to go home. The big difference between this and other engines is this what's called full flow. That is, that the whole flow of both fuel and oxidant is used to turn the pumps which are pumping the flow. That sounds like, what's the phrase I'm looking for? Perpetual motion, yeah. Because you've got to have the stuff going through, and you have to have a starter. There are high pressure spheres of helium which actually start the thing up. And of course, once you've got it going, the fuel gushes through, the fuel turns the turbines turn the pumps, and it keeps it all going. Notice that the fuel, the liquid methane, is circulated around the combustion chamber and the nozzle to prevent them melting. The temperatures inside the engine get very, very high. There's the 2 engines. The one on the left, as you look at it, is the one you've already seen, the sea level Raptor, and the one on the right is the first vacuum Raptor. You notice that it's got a much bigger nozzle. The much larger nozzle takes advantage of the fact that when you're in vacuum, you can let the thrust, the jet that's coming out of the engine expand further while it's still pushing on the nozzle, and so you get a bit more power out of it. The difference can be, under the most favourable conditions, nearly 10% more power in vacuum than at sea level from an essentially similar engine. They have internal pressures of around 300 bar. That's why you need a very powerful pump to shove the fuel and oxygen into them. Because one of the really big dangers of liquid fuel rockets is if the pump isn't powerful enough, when the engine's going, the fuel backs up. And that isn't generally considered to be a good thing and has caused a number of rockets to be lost. Specific impulse, 3,700 metres a second. That's a measure of the power available from the engine. These full flow stage combustion cycle engines, this is the first time they've been used in operational rockets. So Musk and his boys have made a very definite step forward. One of the problems for that was that they had to develop corrosion resistant stuff for the oxygen, the liquid oxygen, because liquid oxygen is nasty stuff. It is quite, I mean, you can't really store it for long because it will corrode almost anything. Just in case anybody isn't sure what 1 bar is, it's got nothing to do with drinks, unfortunately. It's the standard atmospheric pressure, and it's roughly 10 to the 5 Pascal. Now, as I already mentioned, in action you use high pressure helium to start the pumps. It's like having a starter motor on a car. Hydrogen circulates in the walls of the combustion chamber and so on. So the super heavy booster uses 33 Raptor 2 engines. These are a slightly streamlined design. Ooh, something moved. Perhaps I shouldn't lean on it. It's a streamlined design compared with the Raptor 1. It can be manufactured more quickly and presumably more cheaply. The actual Starship, the bit that was black on the top, uses 3 Raptor 2 engines for use inside the atmosphere and 3 vacuum variant Raptor engines for use outside the engine. They haven't flown one with the vacuum variant engines yet. SpaceX reckons that they will soon be producing 500 Raptors a year, and they aim for a cost of $250,000 each. At the moment, it's more like $1 million each. I was surprised it was as little as that, frankly. I mean, these are really high-tech things, you know. So there's a super heavy booster being swung around by a crane. That must be quite a crane. It's lifting just short of 900 tonnes, which is quite a lot of stuff, isn't it, you know. There's super heavy doing a static fire test. That's the moment of ignition. They planned 5 seconds rather, but they only did less than 3 seconds. So things are definitely going wrong. 4 engines failed. So, you know, they sort of talked about 29 out of 33 is pretty good. But actually, that's an awful lot of your spare margin gone. So I think the reliability needs improving. But one thing that was a great success was the new water deluge system. That worked very well, apparently. That's the static fire test seen from a different angle, looking down on it. When I first saw that, I thought it was blowing up, but no, that's just doing the job. I love that picture. This is the top of the booster, that's the bottom of the Starship. And there's the chaps guiding the Starship onto the top of the booster where it will be fixed on. Back along, a couple of years ago, they actually fired up a model Starship. It didn't have many of the features that a real one would have, but they were able to launch it. It went up about 10 miles, the 3 engines all worked, and then it came down again on 2 engines. So there you see it 16 seconds into the flight and it's going, okay, 3 engines firing, it's well clear of the ground. I couldn't get a picture from that actual flight, so this is a different picture, but this is Starship belly flopping back with those little fins providing some aerodynamic guidance, and then later on it fires its engines, goes back into a vertical position and drops onto the ground. Now remember, this is big, this is 50 metres tall. This isn't, this isn't a back garden rocket, this is quite a big thing. And there it is, safely down, all the dust and the fumes are blown away. What the little fire is down by the base there, I don't quite know. I would have thought that should have gone out as well, but apparently it hasn't. Now this is SpaceX HLS, Human Landing System. I stress this is an artist's concept. It ain't got anywhere near the moon yet. And it's quite obviously very similar to the basic Starship design, but it's got legs instead of fins at the bottom and it hasn't got the fins at the top. And it's standing there on a simulated moon surface. The actual landing will be done with thrusters rather than with the main engines, and that's to minimise the effect on the lunar regolith, which is very fine grained and blows up in vast quantities if you put a powerful engine thrust, rather put a powerful thrust on it. Because the human landing system won't come back to the Earth, it just might come back to Earth orbit, but it won't re-enter. So it doesn't need heat shielding, which saves a lot of weight. And even the first ones to get to the moon, it's possible that they can be left in lunar orbit and then reused sometime later, if they can be refueled. And just a reminder, that's what the Apollo lunar module looked like. Sort of. I always think it looked like something that had been designed by Emmett or something like that, you know, or Heath Robinson, but it worked. Now, Starship is bigger than the space shuttle. I had not realised that. Those 2 yellow ellipses are the same size. And you can see the Starship does a much better job of filling its yellow ellipse than the space shuttle did. This is a big bit of kit, and it's very heavy. So NASA has chosen SpaceX to construct the lunar lander, and that will partner the Artemis 3 flight. Artemis 2 will be a round the moon and back flight. Artemis 3 is supposed to be the first lander since Apollo, first human crewed lander. Artemis 3 is supposed to go round the moon next year. They've already flown an unmanned moon mission, which was actually more complex than the one with a crew will be. But I think they wanted to give the Orion capsule a big workout, make sure it would cope with everything. This is the concept. There is the SLS, which launches the Orion capsule and its support module. Then Booster 9, or Super Heavy Booster, will put a spaceship, Starship, into orbit around the Earth. Several more launches will carry up enough fuel to refuel it, so that it can then go up to the moon. The two vehicles will rendezvous. Starship, HLS, will land on the moon with at least 2 people aboard. It will then take off, rendezvous with the Orion capsule again, and the Orion capsule will return to Earth. And that does mean that the Starship can be left in lunar orbit, and if they can find a way of refueling it, then it might be used again. My first reaction on reading that was, why do they need SLS? You know, if they can get this dirty great big thing up there anyway, surely all they need to do is stick a crew in it and it could go to the moon on its own. I'm probably missing something. If you've had a look at the Orion capsule, it's a sort of big version of the Apollo command module. It carries a crew of 4 in considerably more comfort than an Apollo command module, but there's still not a lot of room. And as this picture shows, you can't stand upright. Not that's going to matter very much in space, but you know, it shows you how cramped it is. And you've got 4 people there. There's not a lot of room to spare, is there? I certainly wouldn't want to go on a trip, you know, several months in that thing. Now, Apollo 8, which of course was the first interplanetary mission, Christmas 1968, carried 3 astronauts, and they actually went into lunar orbit and orbited the moon 10 times. They also read out a passage from Genesis, I don't know if you remember, and so on, and they all came back. This is a diagram of the interior of Starship, 50 metres long, 9 metres wide. One of the immediate features here is what they call the common dome. Generally speaking, the fuel tanks and the oxidizer tanks are complete and separate. SpaceX have designed a common dome between the two. This saves a lot of weight and a lot of room. A lot of doubts have been expressed about the safety factor. You know, having all these propellants in these tanks, in some ways the propellant tanks are the weakest part, and having just one bulkhead between the two. Remember, one side is liquid oxygen, the other side is liquid methane. If there's a rupture in that tank, it could be very nasty.
And that was done on Apollo.
That
was done on Apollo.
What, common?
Yeah.
I bow to your knowledge. It's not. I've not seen a diagram of it done like that. You might be right. No. Notice that about 17 metres of this is payload. That you're going to need a lot of, 17 metres long and 9 metres wide. You're going to put 100 people in that to go to Mars. Not be far off sardines. This is another artist's concept. Shows a starship. Oops, not supposed to do that. Shows a starship with lots of cabin windows there. Dreadful weakness in the structure. Approaching Mars. Not sure I'm going to live long enough to see that, but you know. Remember, so far Starship's flown up 10 miles. That's the best it's done, and without a crew. It's not achieved Earth orbit. Unworthy of me to say so, but I do get the impression sometimes that this is a bit of a smokescreen. Keep them thinking about Mars, and won't worry about how far we're really getting. I may be being very unjust, in which case tough. A real trip to Mars, they say, will take at least 6 months. The usual version is over 8 months. Depends on the relative positions of Mars and Earth. 8 months is a long time to spend in a metal box with the same people that you can't get away from. One of the things that I found interesting, you've all heard about these things where they had 8 people in a warehouse outside Moscow and they flew to Mars in theory. If you look into it, you find that there's never been a reunion of any of these crews. Apparently, once the mission is finished, even though it's only a sort of substitute, the one thing they all want to do is go away from one another and never want to see anybody again. You can understand it. And in that 17 by 9 metres, not only have you got to have the crew, you've got to have the life support and any other equipment. I mean, lunar rovers or anything like that. It's all got to be fitted in there. I wish Musk would explain his project for landing a bit more clearly. I'm not, at this stage, to be honest, all that interested in his plans for Mars. That's so far down the line. I'd like to know in a lot more detail what they're planning to do to get on the moon. In videos, of course, Boca Chica is often referred to as Starbase, but it's also referred to as the gateway to Mars. 5 minutes, right, okay. That's the crucial point. Starship and the booster have got to work properly. Or, That's the full launch tower, and the mount, that's the bit down the bottom here where the booster stands on. That's the mount. Those 2 bits sticking out like arms are called chopsticks, and that's the tower. The chopsticks grab the booster. So here is a super heavy test. The booster is descending. At this point it's just falling. It is the right way up. The engines are down here. A bit later, they fire up some of the engines and they bring it under control and straighten it up so it's vertical. They bring it under control, it slows right down, and there you can see it almost stationary next to the launch tower, and there are the chopsticks extended. This is the bit that shook me. The video is fascinating. The booster is hovering on its jets and it is moved sideways into the chopsticks, which then clamp it. I think, that's an interesting idea. And there is the job done. They've doused the engines and Super Heavy is hanging in the chopsticks, presumably with its last dregs of fuel still on board. So a demonstration mission of the lunar lander is due to take place no earlier than April 2025. They started using this form of words with the JWST when they were always behind schedule. So if they said you know, we want to do it by April 2025 and they didn't, that looked bad. But if you said it was no earlier than April 25, well, yeah, April 26 would do, wouldn't it? You know. It's only a year and a half away. There's a lot needs to be done in that time. This morning it was reported that Elon Musk had said on Twitter, Starship is ready to launch. It is only awaiting the Federal Aviation Authority's licence approval. And there is a picture of it standing on the launch pad. Whether that is the right picture or whether it's just a stock picture, I don't know, but that's the way it was presented. So there we are. We have an amazing system which hasn't actually delivered yet, but with any luck it will. And if they keep to schedule, then we could see Americans walking on the moon. I think 2026 is likely to be the earliest date that we're going to see it, but we might do. I think we all cross our fingers, because Musk will be absolutely bloody unbearable, won't he? I can't say I'm a fan of the guy anyway, but
No, I'm not.
yeah, he is going to be unbearable, but there we are.
Thank you very much. A while ago we had Nigel Henbest came and gave us a talk about Virgin Galactic, and he had bought a ticket to go on that. So are you going to be buying your ticket to go on this?
Don't think I could afford it.
Okay, obviously time for questions. Now, we've got a little bit of a sound issue today, so could we ask Miss Roger, if you hear a question, would you repeat it into the microphone
I'll try, yes.
so that the people on Zoom can hear what the question is, and more importantly, what the answer is. So who wants to go first? Yes, Glenn.
You mentioned pollution in the vicinity of the launch pad, but what about the effects on the climate of all these propellants, especially methane? Is a really powerful greenhouse gas. Do you know if any calculations have been done?
Certainly some calculations have been done. Sorry, I should have repeated that.
Yes.
Do we know about the effect of methane on the atmosphere and as an environmental pollutant? Yeah, I mean, calculations have been done. The point is that the methane is burned. So actually what comes out of the rocket is carbon dioxide and water, both in gaseous form and both very, very hot. As you could see in that radar picture, the plume was quite noticeable. Could be picked up easily with a small airport radar. So there are issues about that. Methane, I mean, if for instance the rocket simply disintegrated and they weren't able, I don't know why it would do, but supposing it did, there would be a couple of thousand tonnes of methane distributed into the atmosphere, which would not be a good thing immediately locally. Because methane isn't poisonous and it would be used up by atmospheric oxygen quite quickly, but I still don't think it's a good idea. On the other hand, it's no worse than dumping 2,000 tonnes of kerosene into the upper atmosphere. And some of the other propellants, I mean hypergolic propellants for instance, what they chuck out into the atmosphere is absolutely appalling. Some of these solid fuel boosters, aluminium dust from them can be detected usually about 100 miles from the launch site. So this might be marginally better actually, only marginally.
Thank you, Phil. Thank you, Phil. Any other questions from the floor?
So, are there any plans to test the lunar lander without people on it, on the moon?
Well, presumably
Could you
that's...
repeat the
Sorry,
question?
repeat the question, yes. Stay there and remind me every time, Alan, because I'm going to forget. Yeah. Are there any plans... The question was, are there any plans to test the lunar lander? As far as I understand it, that's the idea of the demonstration mission. I suppose the nearest thing to that in the Apollo program was Apollo 10, which, if you remember, they flew round the moon and they took the lander down to a mile or so up from the lunar surface, but they didn't actually land. So yes, they are planning to test it. If the Chinese do something spectacular, I reckon that's going to push the timescale up, and that bit might get dropped. I don't know. That's just me being cynical. But yeah, there are plans to do it, and I think it's a good idea. So let's hope it all turns out all right.
Okay. Do we have any questions from the Zoom group?
No questions, just a thank you for your research work, for a very thought-provoking presentation.
Oh,
Well,
good.
that's rather nice, isn't it?
Glad someone enjoyed it.
Any more questions from the floor? Okay, well, thank you very much indeed, Roger, for taking the challenge. I know when we gave you the subject, the email I got back sounded slightly, you thought it was challenging, didn't you?
Yes.
We are so pleased how you rose to the challenge.
Thank you.
So if you can think of something challenging for next year for Roger, please send it in
Shut
on
up.
a postcard. But it does give us the opportunity to say thank you again to Roger, because it was after the night class at the SEAL School in Hertford that this group was born, and obviously he inspired us then, especially with his bog roll model of the solar system, which is ingrained on my
It's
mind.
still being used.
I've heard.
Yes.
I'm pleased that people are recycling toilet rolls.
Well, indeed, yes, yes. I have actually genuinely got to recycle my copy of it, because it's reached the stage where you need more people to hold the solar system together than you do just to hold it up. Because you know that I used to unroll it and hold it up. But it's got to such a stage, so I've got to try and peel off all the little stickers and move them 50 sheets up the roll.
And I guess it's changed a bit since we saw it, that you've got a lot of extra minor planets as well.
No, I
No,
haven't.
you haven't.
No, no, I've still got my grotty picture of about 12 asteroids, and that will do. I'm not a vast fan of asteroids, although I must admit I found the Dawn mission fascinating. You know, the one that went to Vesta and Ceres and used an ion engine as well, which is incredible. That's another thing von Braun predicted, by the way, ion engines. I don't think there's anything that we've done so far that von Braun and his mates didn't predict. You know, slingshots, all of that stuff.
Yeah. But I also think that the, you know, laughing apart, you know, the cynicism about the ambition of people like Elon Musk. Without that ambition, things wouldn't happen.
No.
And, you know, I think we have to applaud him for pushing the boundaries of what we believe. But I also think we ought to applaud Elon Musk on having made an electric car that's actually gone further than most of them seem to be going nowadays. If we could all have one that could go that far, I think electric cars would sell a lot more, wouldn't they?
Do you remember that thing was published in the Sunday Sport or something? Picture, obviously faked, of a B-25, was it? Bomber, B-29, on the moon. And I said the problem was, how did it carry enough fuel to get to the moon? Little things like there not being any air on the way. How did they navigate the rotten thing and so on? You know, that got all.
We might have had an AM radio or something.
Well, yeah. God,
Okay,
dear.
well, I think this is a suitable time to wrap up the evening. Just give a little advert that the next meeting here is on October the 11th, when we go back to the second Wednesdays of the month. And we've got Richard Goodrich coming along to talk about how the 1910 return of Halley's Comet almost destroyed civilization. So I think that's going to be a really fascinating talk.
My father was one of the few people who saw it twice.
Oh,
because he was 6 in 1910, and he told me he remembered being taken up to Parliament Hill Fields, I think it was, and seeing this comet. And then in 1986, I took him up to Alexandra Palace with the Astronomical Society of Haringey, and we showed him Halley's Comet. And he said, "Very nice, Roger. Didn't you say something about buying me a drink?" And I thought, there's a man with his priorities sorted.
well, that's fantastic. So I hope that you'll all come along to that. Tickets will be available very soon for that. They're not quite ready yet. Similarly, the website isn't quite up to date. So don't tune in for a few days yet. We will be posting a recording of tonight's meeting on YouTube, probably editing the beginning part of it a little bit so that we make it all nice and smooth. And back editions of previous meetings are also available on there. There's probably about a dozen or so if there's anything that you've missed and want to catch up on. So let me just say thank you very much indeed to yourselves for coming out tonight. Just remember that the first meeting we've had this year, it was so warm, we were all in t-shirts and shorts. I'm sure later on in the year we'll be coming with our overcoats. There is a full programme of events which is publicised on the website, so do catch up there. And lastly, can I say thank you very much indeed to the committee, the team, who've put tonight together in lots of different ways. There's all sorts of things go on in the background to make it happen and to make it run so smoothly. So I do like to say thank you very much indeed to them, and also to the university for providing lovely, comfortable accommodation. So have a safe journey home, and we'll see you next time. For those of you on Zoom, we're going to end the meeting here, but if there's somebody there who wants to take over the hosting, and if you want to have a chat amongst yourselves, by all means volunteer now, and we will switch over so that you can carry on it. Do we have any volunteers there on Zoom? Don't all rush. No, they're all sitting there quietly, because the next thing that will happen is we will be closing the meeting. So thank you very much, all you Zoom people as well. I hope you've enjoyed it. I can see you giving applause there, you can see them.
Oh, that's good.
Yeah, that's good, isn't it? So thanks ever so much. See you next time.